Students, today we are going to learn how to calculate geometric mean. Now, geometric mean is a little bit different than the arithmetic mean. Here we do not add, we multiply all the x values. So, for the discrete series, it is a bit different. For the continuous series, it's a bit different. So, let's go one by one. For the individual series, where we have just individual values, we multiply all the x values. And suppose there are n x values, we take the nth root of the multiple of all those x values. So multiply all the n x1 into x2 into blah 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 into xn, then take the nth square root. So this nth square root is also written as 1 by n. Similarly, the nth square root of x1 to the power f1 into x2 to the power f2 into dot 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 into until xn to the power fn. So here again you can write it as 1 by n, but here notice the frequencies are the powers of the individual x values, and n, which is the total sum of all the f's or the frequencies, is the root value. So for each individual x, we first take to the power the frequency and then we do this. Now when we take log, this makes life easier for us, which we will see below. But the continuous series, the geometric mean formula is you take the mid value of each class interval and then take it to the power of the frequency. So m1 to the power f1, m2 to the power f2, and so on until mn to the power fn and the nth root. So here we are taking each m to the power of its frequency, each mid value to the power of its frequency. This is for the continuous series. Now, for convenience of our calculations, we use the log value. So if you have a scientific calculator, you can use the log value, or you can use the log table, which I have already talked about in the class. So when you take the log of geometric mean, what happens is, due to the properties of log, the power of the square root becomes 1 by n. So you get 1 by n into, it becomes multiplication problem into, and each multiplication problem becomes a addition problem. So first of all, the power becomes a multiplicator, and the multiplication problem becomes an additional problem. So it becomes log x1 in plus so on until log xn. So log x1 plus log x2 plus log x3, so on until log xn. This we can write in the short form sigma log x. So we are adding all the log values. Now this is for the individual series. What about, so once we have calculated the log values, to find the actual geometric mean, because we are getting here the log of the geometric mean. How do you get the actual geometric mean? You have to take something called the anti-log, which if you have a table, it's very easy. Otherwise, you can input it in the calculator and calculate the anti-log value. Now, log of geometric mean for the discrete series is a bit different. So here, just like the previous individual series case, rest all is very similar. Only thing is each frequency is multiplied to the log x value. So f1 into log x1, f2 into log x2, so on until fn into log xn. So this power again becomes a multiplication. Just like 1 by n was the power and it became a multiplication problem, x1 to the power f1 became a multiplication problem now. f1 into log of x1. Alright, so this can be written in the short form, sum of all frequencies multiplied by the log value of the x's multiplied by 1 by n. Now when you want to, in this case, find the geometric mean value, you have to take the anti-log of the sigma f into log xi by n. Now for convenience sake, to understand, let's look at problems. Alright, then we'll come back to the continuous series. Now if you look at this problem, in the individual series, we are asked to find the geometric mean. What do? We first write down the x values, then we calculate the log x values, and then once we have found the log x values, we take the sum of those log values. So sigma log x. Now if you remember, that was our formula here, sigma log x. All right. Okay. So now take these sigma log x and into 1 by n. So we are dividing by the n value here. All right. So the n value is 5 because we have 5 observations here. 1, 2, 3, 4, 5. So 4.712, which is the sum of all the log values which we calculated, divided by 5. Once we find this value, which is equal to 0.9424, we take the anti-log value, which gives us the geometric mean of 7579. Now this is the simple way in which we calculate for the individual series. Now what about the discrete series? Let's look at a discrete series problem. Now in the discrete series, let me expand it a bit. So we are asked to find the geometric mean. So we take all the x's. Let me take the highlighter. So we take all the x's. We take all the frequencies. Then what do? We take first the log value of the x's. So log 10 is 1. Log 20 is 1.3. Log 30 is 1.48. So we calculate all the log values for the x's. Then we multiply the frequencies with the log values. So 12 into 1, 12. 15 into 1.3, 19.5. 25 into 1.48, 37. 10 into 1.6, 16, and so on. All right. Once we have done that, we calculate the sum of the frequency into the log values. Then what do? We take this and we divide it by n. So when we replace the values here, we get 98.26 divided by n is total of all the frequency values, which is 70. So once we have calculated that, we put it into the formula and we get 1.404. So that is the log value. Now we have to get the geometric mean, we take the anti-log value of that and we get geometric mean of 25.35. So this is the method for calculating it for the discrete series. Now for the continuous series, it's very similar to the discrete series. Only thing is, instead of x, I take m's here. So mid values. So instead of x1, I take m1. And instead of x2, I take m2. And instead of xn, I take mn. So I take the mid values of all the class intervals. I take their log values. I multiply with the respective frequencies. And I add all these f into log values. Then I divide it by n. So the short form is 1 by n into sigma fi into log m. And then finally, to find the geometric mean, I take the anti-log value. All right. So let's see a problem in action. So we are given the class intervals here and we are asked to find the geometric mean. So we have 10 to 20, 20 to 30, 30 to 40, and so on. So we first take the mid values of each class interval. Then we write down the frequencies, respective frequencies. We find the total is n is equal to 60. Then for each mid value, I find the log value. Okay. So this whole column is the log values. Then once I found the log values, it's very simple. Multiply the frequency with each respective log value. So 8 into 1.176 is 9.408. 12 into 1.397 is 16.774. So on. So multiply each frequency value with the log m value. And then gives me the total f into log m value of 91.2191. Once I have done that, I put these values into the into the formula. And the formula is anti-log of sigma f log m divided by n. So sigma f log m I have already calculated as 91.21. I replace it into the formula. The n is equal to 60. Now I get the value as 1.5203. I take the anti-log value of that to get a geometric mean of 33.13599. Okay, so this is how we calculate the geometric means.